Hey guys, today we're going to talk about chain rule. So chain rule is when we have a function inside of another function and we want to find the derivative of that. So when we have a compositions of functions, here's what we have. Now in your formula notebook, it says that if y is equal to g of u and u is equal to f of x, so if we put those into that, that's g of f of x, then to find the derivative of dy dx, we would have to take the derivative dy with respect to du, that's going to be that g function in there, and multiply that by du dx, which would be the derivative of that f function in there. Now, to me, that formula is confusing. So here's how I think of it. When we are trying to find the derivative of a composition of functions, we're going to take the derivative of the outside, keep the inside, and then multiply by the derivative of the outside. So I'm going to write that out. We're going to take the derivative of outside, keep inside, multiply by derivative of inside. Good deal. So let's look at an example. So we want to find the derivative of y equals x squared minus 2x plus 6. So real quick, let's think of this. Let's pretend that x squared minus 2, let's call him m. Right? So we have m to the 6th. Now if we wanted to find the derivative of m to the 6th, remember we would bring that constant out front and multiply it, so you end up with 6m, and then we'd subtract 1 from the power. 6 minus 1 is 5. So when we start finding the derivative down here, dy dx, the derivative of the outside works the same way. The 6 comes out front and multiplies. Remember, the inside stays the same, so that's going to stay x squared minus 2x. And we subtracted 1 from the power, so now that's 5. So now we're going to take that and multiply by the derivative of the inside. So now we're just going to look at that x squared minus 2x. So I'm going to put some parentheses here. So remember, I'm going to have to bring my 2 down and multiply out front. So we have 2x. 2 minus 1 is 1, so we don't need to have a power on that. And then here, we'll bring that 1 down and multiply and get negative 2. Subtract 1 from the power, so we have x to the 0, or that's just 1. And that's it, guys. That is how we find the derivative with chain rule. Cool, let's look at one that's a little bit more complicated. So over here, we have 4 over the square root of 1 minus 2x. So what I'm going to do is I'm going to rewrite this with exponents. So we know that a square root is the same thing as being to the 1/2 power. And we also know that when we have a power that's in the denominator, oops, forgot my x, we can bring it up to the numerator and make him negative. So we're going to look at just the outside stuff to find my derivative. I'm going to take the derivative of the outside, bring this down and multiply. 4 times negative 1/2 is negative 2. Inside stays the same. We'll subtract 1, so we're going to subtract 2 over 2 from negative 1/2, and we'll get negative 3 halves. Cool. Now we're going to look at that inside and find the derivative of him. We're going to multiply by our derivative. The derivative of a constant, the derivative of 1 is 0, so we'll just ignore him. And then the derivative of negative 2x is negative 2. So you can keep it like that, or we have negative 2 times negative 2 makes that positive 4. 1 minus 2x negative 3 halves. You could also write this as f prime of x equals 4 over 1 minus 2x to the 3 halves. Or you could write that as f prime of x equals 4 over the square root of 1 minus 2x, and that whole thing cubed. So this answer, this answer, this answer, this answer, I'm happy with any of them. Where you stop simplifying is pretty much when it stops helping you. It's going to depend on the problem. A lot of times when you're finding the derivative for certain reasons, it might be easier to plug it in one spot than another. So, okay, let's take a look at some other ones. So my advice is to always rewrite this. So this is the same thing as f of x equals 2x minus 1 to the negative 9th. So we'll start to find our derivative. We'll take the derivative of the outside. We'll bring our power out front. 1 times negative 9 is negative 9. The inside of that 2x minus 1 stays the same. Then we subtract 1 from our power. Negative 9 minus 1 is negative 10. Then we'll multiply by the derivative of the inside. The derivative of 2x is 2. And the derivative of 1, the derivative of any plain old number, is 0. So just multiplying by 2. So then at this point, you can leave it like that if you really want to. If I were you, I would at least multiply together the negative 9 and the 2 to get negative 18. 2 minus 1 to the negative 10th. Or you could write that as negative 18 over 2x minus 1 to the positive 10th power. Ooh, my face is in the way. There we go. Okay, now let's try this next one. So we're going to take the derivative of the outside. So that means we're going to multiply by our power out front. 1 times 23 is 23. The inside stays the same. 4x to the 9th plus 6x. And then we'll subtract 1 from our power. 23 minus 1 is 22. Then we got to multiply by the derivative of the inside. So we'll bring our power down and multiply. 4 times 9 is 36. X to the, and then we're going to subtract 1 from the power. 9 minus 1 is 8. The derivative of 6x is just 6. Now, I would not want to multiply that out, so if I were you, I'd just leave it like that. Cool. Let's take a look at another one. Now, on ones like these, I'm always going to tell you first rewrite it into exponents instead of having radicals. So this is going to be the same thing as y equals negative 2x to the 4th plus 5. The exponent there is 1 because there's nothing written there, and my root is 4, so it's going to be to the 1/4 power. So now when we start to find the derivative, we're going to take the derivative of the outside. So I'm going to bring this 1/4 out front and multiply. So we have 1/4 times. And then that inside doesn't change for right now. Negative 2x to the 4th plus 5. And then we'll subtract 1 from the exponent. So 1/4 minus 1, or minus 4 over 4, is going to be negative 3/4. Now we're going to multiply by the derivative of the inside. So times. We'll bring this 4 down and multiply. Negative 2 times 4 is negative 8. We have our x. 4 minus 1 is 3, so x is going to be cubed. And then the, derivative of a constant of 5 is just 0. So I'm going to ignore him. All right. So if you wanted to start combining things and simplifying, you absolutely could. So if I took 1/4 times negative 8x cubed, or really negative 8x cubed divided by 4, I'd end up with negative 2x cubed times negative 2x to the 4th plus 5 to the negative 3/4. Or we can write that with a positive exponent, negative 2x, there we go, cubed, over negative 2x to the 4th plus 5 to the positive 3/4. Or, I'm going to move it over a little bit more. Cool. We could turn that guy back into a root, or a radical, I'm sorry. So we would have the 4th root of negative 2x to the 4th plus 5, and that whole thing will be cubed. Cool. Let's go ahead and try that last one. So we will rewrite this with just exponents. So this is the same thing as 4x to the 4th plus 3 to the negative 5th power. To find our derivative, dy dx, we'll take the derivative of the outside. So I'll bring down that negative 5. The inside doesn't change. Subtract 1 from our power, negative 5 minus 1 is negative 6. Then we'll multiply by the derivative of the inside. So I'll bring that power out front and multiply. 4 times 4 is 16. We'll subtract 1 from the power. 4 minus 1 is 3. Then the derivative of that constant there of 3 is just 0, so we don't have to worry about him. Okay, so now we can start cleaning this up if you'd like. So we can take negative 5 times 16. Negative 5 times 16, let's see, that's negative 80, right? Negative 80. If that's not negative 80, pretend like it's whatever negative 5 times 16 is, though. And then we still have that x cubed. And then that's still going to be multiplied by 4x to the 4th plus 3 to the negative 6th. Or we can rewrite that with a positive exponent. We'll have negative 80 x cubed over 4x to the 4th plus 3 to the positive 6th. All right, go ahead and try your practice. See you guys later.